This problem says find the partial fraction decomposition of the rational expression. So here's our rational expression here. So what we're going to do with this is we're just going to try to break this down a little more. There's a lot of reasons why we do it, and we don't really see those reasons here in pre-calc. But in calculus, there's these things called integrals, and in this form, to do an integral would be terrible, or we might not be able to do it. So that's where this process comes from, to use it for. So what we're going to do here is we're just going to break this up into two pieces. So I'll show you how to do that. So first off, we're going to put the x plus 1 under here. And then for the other one, we're going to put the x squared. Oops, I don't need the the parentheses there, so I'm going to take those away. So that's x squared plus 4 under there. So what we're going to do with this is we're going to actually split it up into these two. So the first thing we're going to do here is I'm going to put an a up here. Now I'll tell you why I picked an a here. So down here, this has a degree 1 polynomial. And up here, this has to be a degree less. So it's a degree 0 polynomial because a is a constant. Okay, so that's how we think of it here. So now when I look at this next polynomial down here, that's an x squared plus 4, so that's a degree 2 polynomial. So this means up top, up here, I have to put a degree 1 polynomial. So the way I'm going to write that is, I'm going to think of bx. Now, although bx would be a degree 1 polynomial, it's not every possible combination of degree 1 polynomials because it could be like a plus 2 or a minus 4. So what I'll do here is I can just put a plus c, and c could be positive or negative to account for a plus or minus there. So I have to think of every possible combination of a degree of that polynomial. So that's how I would do it. Okay, so now what I'm going to do is from this process now, I'm going to add these together. So what I mean is I'm going to take those two and add them together. Now I'm just going to put this aside for now and work on adding those together. Now, do you guys remember how to add rational expressions? I have to get like denominators. So that means I'll have to take this one here and multiply it by an x plus 1. So that means I'm going to have to take this one here and multiply the top by x plus 1. And for this one on the left here, I'm going to have to take this down here and multiply it by x squared plus 4, which means I'll have to multiply the top by x squared plus 4. So that's what I'm going to do now. Now, keep in mind here, guys, I'm going to multiply the tops, but I'm going to leave the bottoms in this factored form. I'm not going to actually multiply the bottoms through. I'm just going to keep them there. Okay, so that means I will end up getting, for the top, ax squared plus 4a. And then for the bottom, I'm just going to have that x plus 1 times x squared plus 4. Now also keep in mind here, too, that the bottom here, that this x squared plus 4 here is prime. If that was a minus there, then yes, I could actually factor it. And if I can factor that some more, that changes this problem. Because if this could be factored into two problems, or I should say two polynomials, then that would add another thing I have to plus here. So be careful with that. So if that's not prime, I have to go further, but this one is prime. The sum of squares is prime, but the difference of squares I can actually factor. So if I could factor that, I have to factor that before I start my problem. And that will add another rational expression I would have to add. So just kind of keep that in mind. So anyways, back to our problem here. So then on the bottom, I'm just going to keep that same factored form. So this is going to be my x plus 1, and this is going to be my x squared plus 4. So then on the top, don't forget here, this is actually a FOIL that I'm doing here. So I'm going to have to multiply that through and get all those four products. So the first product here is going to give me bx squared. Now that's this one here. Okay, now I'm going to do the next one. So that's bx times 1. So that's going to be plus bx. And I'm just going to keep going with this. Plus cx. and plus c. So now I have both of these multiplied out. Now what I'm going to do is I'm going to add these. Now again, I'm going to add them in a different way. So I'm just going to take this, not really in a different way, I'm just going to write it a different way. So this here is going to be an ax squared. And I'm going to put the 4a way over here. And you'll see why in a minute. Because remember here, I'm adding these. Okay, so just something to kind of keep in mind, I'm adding them. So that's going to be my ax squared and then my 4a there. Now below, I'm going to write my bx squared. And essentially, I'm just trying to match them up here by degree terms. So then I'm going to have a plus bx plus cx. And then on the end, I'm going to have my plus c. Now you noticed I separated them that way so I could actually split them up. So here's my x squared terms. Here's my x terms down here. And then there's my number terms. Okay, so those are just going to be my constants. And that's what I'm getting at with this. Okay, so anyway, so now I'm going to think about how this all works together here. So now, when I think of adding my x squared terms together, that's just going to be an a plus b. Okay, now, when I'm thinking of those x squared terms, I look at my original expression on top here. And this is really 0x squared plus 0x plus 1. So that means when I add my a plus b together, that it has to equal 0. And that when I add my x's together, that also has to equal 0. And then when I add my 4a and my c together, I have to get a 1. So those are my three equations that I'm actually going to be working with here. Okay, so now, like I said before, when I add my a plus b, that's going to equal 0, right, because I don't have an x squared term there. And then my b plus c, which I get from these two, that's going to equal 0. And then that 4a plus c, that's going to equal 1. Okay, because I do have a constant here, and those are both constants. So when I add those together, they have to equal 1. So in essence, what I'm doing is I split them up so that I can get back to that idea. And then I can find out what a, b, and c are going to be. So now this is why we needed the previous section at 11.1, because now I have a system of equations here. And what I have to do with those equations is I have to find out a, b, and c in any way, shape, or form. Now I could set this up as a matrix and work it that way, or I can take this top one here and say, hey, let me get it in terms of a equaling some number. And then I can plug that in down here, and then I can take these two equations together. So that's going to be the way I'm going to take this problem. And there's various ways to do it. You might not like it that way, so pick a way, make sure you're comfortable with it. So I'm just going to do that first thing here. So this, I'm going to say a equals negative b. And then all I'm going to do here is take this, and wherever I see a, I'm going to plug in negative b for it. So that's what I'm going to do first. Okay. So that equation then is going to be 4, negative b plus c equals 1. So now I'm going to clean this up a little bit. So that's going to be negative 4b plus c equals 1. And then I'm going to take this second equation, because I didn't use that one yet, and I'm just going to bring it over here. And that was my reasoning for this. I seen that one equation was a b plus c, and one was an a plus b, and then one was an a and a c. So I can get two equations to unknowns. And that's really what I'm looking at here. And I know how to solve those, right? I can use either the elimination method or the substitution method. I'm going to use the substitution method here. And I'm going to take this bottom one because I seen the 0 there. And that's actually going to be c equals negative b. And I'm just going to take that and plug into the one above it. So that's going to give me negative 4b plus, and then instead of putting the c there, I'm going to put the negative b there. And so I'm placing this one here. Okay, and then that equals 1. So this is going to be negative 5b equals 1. So then I'm going to divide by that, so I get my b equals negative 1/5. So now that's that one. So now we can find the other ones. Because I know a plus b equals 0, like in the beginning there, you see up here. So I can say then, if I just use this equation here, I can say that a equals a negative b right? And then that means a equals 1/5. So there's another letter I have. And then I go along and try to find the c now. And then now, using this equation, I can say, hey, that tells me also c has to be a 1/5. Just because the same way a was. So then c equals, oops. So now that I have all my values for those, now I'm just going to go back to these problems we came up with, or these equations we set up, or these expressions we set up. And I'm just going to plug in the 1/5 for them, or the negative 1/5. So I'm going to plug in a, b, and c. I'm sorry, not in these ones here. Not in those. I'm actually going to plug them into these here. Without this x squared minus x squared plus 4 stuff. Just the a's and the b's there. So what I'll get is, so here we go. I just kind of want to show you what I was actually picking. So I just rewrote it down below here. So now what I'm going to do is I'm going to take this and plug everything in for it. So then this is my x plus 1 down here. And my a was positive 1/5, so I'm going to put a 1/5 here. And then my b was a negative 1/5. So negative 1/5 here for bx. Plus, and then a positive 1/5 for my c. And that's going to be over x squared plus 4. Now that's going to be my start of this. Now my final answer for this then is going to be where this 5 can actually go to the bottom, because that's really what would happen there. Okay, so this would equal, so 5x plus 1 down here, and then there'd be a 1 on top. And then this, I could leave the negative on top, or I could actually make this a minus here. And I think either way would be acceptable for me, but be careful how you do the minus there. I will have the 5 on the bottom, and then I'll have an x squared plus 4 down there. And then on the top, I'm going to have an x. Now that will look positive up there, and then this will be a minus 1. Because if I pull a negative out, that's going to change both of those signs. So now I get the positive here and then a negative for that one. So this would be my final answer. Oops. Now again, in this class, we just learned how to separate this into a sum. And the reason for that is later on we're going to talk about these things called integrals, and that's where we actually use this process for. So we won't see that here, but in calculus you will. Calc 1. There we go, we're done.